Okay, welcome to Learning Target 4 and 5 of Chapter 1. First of all, the learning targets for this video are going to be: I can express a whole number as a product of its prime factors using prime factorization. So, first of all, I want to go ahead and put a bracket. That's called a bracket right there. Right there. A product of its prime factors. We'll talk about that more here in a little bit. And learning target number 5, you need to be able to identify whether a number is prime, composite, or if it is neither. Okay? So, really not difficult here, but can be difficult. Okay? Alright, let's go ahead and flip in your notes to page number, I believe, 10, but let me get there to see. Keep going. Yep, right here. It should look like this. Page 10, yeah. And as you can see, this is where it starts. Okay? Now, we are going to be, like I said, we're going to be doing prime factorization, which I'll show you what that is here in a minute. I'm going to cover this first, like learning target 5 first here. Okay, we're going to learn what a prime number is and what a composite number is. Now, the first thing you got to know is what a factor is. Okay, you're going to hear me say the word factor a lot over the next year. The entire year I'm going to use it, because this is really a skill, this skill right here, that you're going to use pretty much every chapter for the rest of the year. So it's very, very, very important to understand it. Okay, factors, numbers that are multiplied to get a product. Now, that definition may be kind of confusing to you, so I think it's easier to give you an example. So let's say I told you the number 6. If I asked you to find the factors of the number 6, what factors are? They are the numbers that you can multiply together that would give you 6 when multiplied. For instance, I know that 1 times, remember the dot means times, 6 equals 6. So I know that 1 is a factor and 6 is a factor. Okay? 1 and the number is always going to be a factor of the number. Okay? But also, you can do 2 times 3 and you can get 6. So right there, I know that there are my factors. So the number 6, if I asked you to list out the factors of 6, you would say 1, 2, 3, and 6. Okay? Hopefully you'll understand that. Those are the numbers that'll multiply together that'll get you 6. We'll do another one real quick. Let's do 12. I know that 12 can, obviously 1 times 12 gives me 12. 2 times 6 gives me 12. 3 times 4 gives me 12. So if I asked you to give me all the factors of 12, you would list them out in a list just like this. 1, 2, 3, 4, 6, and itself. Just keep in mind that every number you can think of has 1 in itself, because we know that 1 times anything is that number. Okay? Obviously, you get higher numbers. If I told you 5,668, something like that, it would have a lot of factors. Okay? But the one I know for sure is that it has 1 and that number as factors. So hopefully you know what factors are. Okay? Because you got to know what factors are in order to be able to identify prime and composite numbers. Pretty basic here. Prime numbers only have the 2 factors, 1 in itself. So let me give you an example of a prime number. So I'll write prime right here. A prime number would be like 7. What way can I multiply 2 numbers together to get 7? Okay, I can do 1 times 7. That would give me 7. But is there any other way? Can I do 2 times anything, 3 times anything, 4 times anything? No, I can't. That is what a prime number is. Okay? That's a prime number. Another example of a prime number, 3. Because the only way I can get to 3 through multiplication is by doing 1 times 3. The number 2, the only way I can get to 2 is by doing 1 times 2. So that's what a prime number is. Well, if that's a prime number, then a composite number is a number greater than 1 with 2 or more, with more than 2 factors. So in other words, it has at least 3 factors. Okay? So the numbers I gave you here, like 6, like 12, those are composite numbers, because not only do they have the 2 that all have 1 in itself, they also have another, at least one more factor other than 1 in itself. Okay? So composite numbers, I'll go down to this thing, this little chart here. Here's even and odd numbers. We talked about that the other day. It's whatever it ends in. So if it ends in a 0, it's an even number. If it ends in an 8, a 6, a 4, a 2, it's always going to be an even number. Odd numbers are going to end in 1, 3, 5, 7, and 9. Okay? So here, I know that 16 is a composite number because I know that I can do 1 times 16. I know that I can do 2 times 8. I know that I can do 4 times 4. Okay? And because of that, I know it has to be composite because it has more than 2 factors. It has at least 3. Now this one happens to have 5 total factors because it has 1, 2, 4. I forgot 8. Or no, I didn't. It has 5 factors. Sorry. It has the 5 factors. So there you go. 24 is the same way. It has 1 in itself, obviously right there, but then it also has all these other factors. 2 times 12, 3 times 8, 4 times 6, all those make up factors. 19, the only way you can get to 19 is by doing 1 times 19. If you go to a multiplication chart, you're never going to find 19 on it unless it went big enough to where it was 1 times 19 or 19 times 1. So that would be prime. Here, 65. Yes, I can get there by doing 1 times 65, but there's also another way, and it's by doing 5 times 13. So this fits the criteria of having at least 3 factors because it has 1, 2, 3, 4. Therefore, it's a composite number. Let's go ahead and go to the next page. So now we look at 47. Okay, 47. And by the way, if you're ever going to check, you can just check it by doing 47 divided by 2. See if it gives you a whole number. 47 divided by 3. See if it gives you a whole number, and so on. Okay, we know that every number has 1 in itself. Okay, if you went through all that process, you would find that it is a prime number. Now you're going to learn some rules so you don't have to divide them here in a minute. Here's 33. I know the number 1 and I know the number 33. Obviously, it has those 2 factors because 1 times 33. But this one also has 2 other factors. 3 times 11 makes 33. There you go. And the one I want you to pay attention to is the number 1, and it is neither. And the reason it is neither, because how many factors does it have? It only has 1 factor. So everybody write that. Only has 1 factor. Okay? Remember, prime numbers have 2 factors. Okay, that's what makes a prime number a prime number. It has 2 factors. The number 1, the only way you can multiply to get to 1 is by doing 1 times 1. So this only has the factor of 1, which is only 1 factor. Okay? Okay, listing out the first 15 prime numbers. Okay, so obviously we just went over this. 1 would be eliminated. Okay. Now I'm going to go to, and the reason 1's eliminated because it's neither. Now I'm going to highlight or circle. If you don't have a highlighter, that's fine. Okay. I'm going to go ahead and circle. I'm going to go ahead and highlight 2 because I know the only way I can multiply and get a product of 2 is by doing 1 times 2. Therefore, it only has 2 factors. I know that 3 is the same way. Now, before I go any further, understand every even, actually, you know what? Let's jump ahead. Let's jump to the next page real quick. Now, this is just terrible the way it looks on my screen. I think it looks better on yours, at least I hope. Okay? These are called divisibility rules. We talked about these on review sheet 1. These divisibility rules will help you. They will keep you from having to, like if I had this number 478, if I wanted to know if it was divisible by 2 or if it had a factor of 2, rather than actually doing 478 divided by 2 and doing the process of dividing, I can just look at it. I can say, does it have a last digit, a ones place value that's even? Because all even numbers have a factor of 2. Remember that. These are the divisibility rules that you need to learn. You're going to use a lot, okay? the last digit is even. Okay, if it's even, it is not a prime number, except for the number 2 itself. Every even number after, go back to this now please, every even number after 2 is going to be composite, because we know, like 4, we know that it has a factor of 1 and 4, but we know it's even. So therefore we know that it has a factor of 2. So 4 is gone, 6 is gone, 8 is gone, 10 is gone. All these are gone because they're even numbers. Even numbers are always divisible by 2. Okay? 18, 20, 22, 24, 38, 40. Go ahead and keep marking them off here, all your evens. And we know those are composites because they are even and they are divisible by 2. Okay? Now that you're done with that, let's go ahead and flip back to the divisibility rules page. Now you're going to have to look at yours. You won't be able to look at the screen very well here. But basically, what the rule for 3 is, and it's very useful, trust me. Okay, very, very useful. Okay? And what it is if I had the number, I don't know, 414, something like that. If I had 414, sure, you could just get it and actually divide it and say 3 goes into 4 one time, multiply. You could do the long division, but I'm trying to get away from that method. Okay? What I want you to do is I want you to learn this divisibility rule, and I'm going to ask you this divisibility rule for the rest of the year, and you're going to be required to use it. Basically, here's how the rule works. You're going to take that number, you are going to add up, and by the way, I know you can't write over the top of yours, just write off to the side, and you just add up the digits. So because it's 414, I'm going to add 4 plus 1 plus 4. So 4 plus 1 is 5, 5 plus 4 is 9. When you get that, that is your sum, and then just ask yourself, does 9 have a factor of 3? Yes, it does. And I can ask this two ways. I could say, does 9 have a factor of 3? Or I could say, is 9 divisible by 3? And yes, it is, because 3 is a factor, because 3 times 3 is 9. Now, if I gave you a different number, let's say I gave you 5,152. Okay? If I gave you this number right here. Okay, now we're going to check to see if 3, it has a factor of 3. So we're going to add the digits. So here we go. We're going to do 5 plus 1 plus 5 plus 2. So 5 plus 1 is 6. 6 plus 5 is 11. 11 plus 2 is 13. Now that we have that sum, is 13 divisible by 3? No, it is not. Again, another way I could ask it, does 13 have a factor of 3? No, it does not. So therefore, this number right here does not have a factor of 3. Okay? Now, does it have a factor of 2? Yes, it does, because it ends in an even number. But I'm just trying to show you the divisibility rule. So going back here now, let's go through. We only have odd numbers left. So let's look. Let's look at the number 5. Does that have any factors other than 1 or itself? No. 7. The only way you can get to 7 is by doing 1 times 7. Okay, here we got 9. If you think about it, you can do 1 times 9, but can you also do 3 times 3? Yes, you can, so it's composite. Okay, 11 is prime. 13 is prime. 15 is composite. 17 only has 1 times 17. 19 only has 1 times 19. 21, be careful, one that a lot of people think is prime, but remember, 3 times 7 is 21. Okay? 23 is prime. Let's go back to our divisibility rules real quick here. Divisibility rules. Okay? Now 4, you can look through any number. 4, basically the rule is pretty basic here. So let's say you had 4,000, or let's go 436. And if you wanted to know, is that divisible by 4? You just look at the last 2 digits and you say, okay, 36. Is 36 divided by 4? Yes, it is, so therefore 436 is divisible by 4. Okay? That one's used some, not as much, because well, it doesn't matter why, but let's just leave it at that. It's not used as much. 5, if it ends in 5 or 0, then it is always divisible by 5. Always. So, going back here, I can now eliminate anything that ends in a 5 or 0, because think about it, 5, 10, 15, 20, 30, 25, 30, 35, 40. Every multiple of 5 is going to end in 5 or 0. So that means I'm going to get rid of 25. 30 is already gone. I'm going to get rid of 35. 40 is already gone. I'm going to get rid of 45. And now I'm going to get rid of 50 if it was already there. And then 55 if it was listed here. Okay? 27. If you don't know that 3 times 9 is 27, use the rule. Remember the rule? Add the digits. 2 plus 7 is 9. Is 9 divisible by 3? Yes, it is. So that would be a composite number. 29 is prime. 31 is prime. Again, get to 33. Check your rule. 3 plus 3 is 6. Is 6 divisible by 3? Yes, it is. 37. Okay. 39, one of the most missed ones every single time I do this one. Okay. Use your rules. You just can't assume. You just can't say, oh yeah, I think it's prime. I think it's prime, so I'm just going to circle it. No, it doesn't work that way. You got to go through your checks. You got to check it. The first thing you ask, is it even? And if it's even and larger than 2, then you know it's composite. But if it's odd, this is where you got to do some work, and you always want to check 3, 5, 7, and 9. So if it's an odd number, you're always going to want to check 3, 5, 7, 9. Okay? So we start at 3. You don't need to pull out your calculator and do 39 divided by 3. You don't need to do that. I want you to use the rule. 3 plus 9 equals 12. Is 12 divisible by 3? Yes, it is. There we go. So therefore, that is a composite number. Okay, 41. Okay, it's odd, so we don't have to worry about any even factors. So we do 4 plus 1, that's 5. Is 5 divisible by 3? No. Does it end in 5 or 0? No. 7, there's no real rule for 7. We don't pay attention to it anyway. You just think about, is 41 divisible by 7? You may have to actually do this one. Okay, and you would find that it is not. It is a prime number. Okay, 43 is also a prime number. Okay, 47, also a prime number. 49, one of the most missed ones out of any of them, because we got to remember that yes, 1 times 49, but also 7 times 7. So that's a composite number. And then 51, check 3, 5, 7, 9. We check 3. 5 plus 1 is 6. Is 6 divisible by 3? Yes, it is. Therefore, it has the factor 3, so it is composite. So the first 15 prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. So keep that in mind. Okay. Alrighty, now we're going to practice the other part of the learning target, okay? And it's prime factorization. And here's what prime factorization... Oh, actually, we're going to do this at the end here in a minute, so just be patient on that. We'll come back to it. Okay, skip that page. Go ahead and now work on prime factorization. What prime factorization is it's very similar to what you learned as your factor trees, kind of. Okay? And I'm just going to show you an example here. So, basically, you're always going to start with a little tree, and you're going to break this into 2 factors. Okay? Because you can see the word factor right there, so prime factorization. So the idea is to get your factors to become prime factors, usually one of those first 15 that we talked about. So the 2, 3, 5, 7, and so on. Okay? So you ask yourself, what could 81, what 2 numbers would multiply to give me 81? Now some of you might be saying, well, 1 times 81. Okay, that will not work. Here's why. This is called prime factorization. Is 1 a prime number? No. 1 is not a prime number, so you're never going to have 1 on a factor tree like this because it's not prime. Okay, so you've got to think of a new way to go about doing this. We've got to find a new set of numbers, 2 other factors. Okay, maybe you need to check 3. It's an odd number, so remember, whenever it's odd, we're going to check the numbers 3, 5, 7, 9 every time. So we're going to check 3. 81, we're going to do the rule for 3. 8 plus 1 equals 9. Does 9 have a factor of 3? Yes, it does. So I know that 3 is a factor of 81. So if I'm trying to find out this other factor right here, this is where you got to do some division, okay? Because remember how multiplication works. If I do 4 times 3 and that equals 12, well then if I do 12 divided by 4, it's going to give me the other factor, okay? 12 divided by 3 is going to give me the other factor. So basically, you've got to do 81 divided by 3, okay? And that will give you 27. Now, this is where you've got to now determine whether or not either of these are prime. Okay, hopefully you all are going to realize real quick that 3 is absolutely prime. It only has 2 factors, okay? 27 is not prime, so we're going to do another tree. When they become prime, we circle them. Okay, same thing here. 27, hopefully you all know that it's going to be 3 and 9. And I know that, once again, 3 is prime. It only has 2 factors. And then we got to go even further with 9 because that'll break down to 3 and 3. And circle them and circle them. That is a tree. That is not the prime factorization. That's the factor tree. The actual prime factorization is when you take everything you have circled, all the prime factors, and line them up just like this. 3 times 3 times 3 times 3. Okay? And that's, if you actually multiplied those out, what do you think it's going to give you? 81. Okay, that's the whole point of it. Okay? Now, for some of you that might be sitting there saying, now wait a minute, Mr. Garrison, what if I would have just done 9 and 9 from the beginning, because 9 times 9 is 81? It doesn't matter, because it still breaks down to the same exact thing. 3 times 3 times 3 times 3. Everybody see that? Let's do another one. Okay, first question you're always going to ask yourself whenever you're doing this. Is it even or is it odd? That's where you start. And if it's an even number, what's it divisible by? Hopefully you're all saying 2. Okay? And then you got to do 56 divided by 2 to figure out what this factor is. 28. There we go. Okay? Now, that's prime. That's why I circled it there, because prime numbers need to be circled. And that's prime because it only has 2 factors. Okay? Next thing I notice, once again, that's even. So again, I know it has a factor of 2. Okay? All even numbers do. Alright? So now this is still even, so I know I can get another 2 out of it. 2 and 7. Because 2 times 7 is 14. Now I've got to determine, is 7 prime or can I go further with it? Okay, it is prime. You can't go to this. That's wrong. Okay, you don't go to 1. There's no 1 on prime factorizations. 7 is prime because it only has the 2 factors, 1 in itself. Therefore, there's my factor tree. My actual prime factorization would be 2 times 2 times 2 times 7. And what's it going to equal? Obviously 56. And then you should always check it. 2 times 2 is 4. 4 times 2 is 8. 8 times 7 is definitely 56. Okay, next one. Here we got 71. Remember, is it even or is it odd? It is definitely odd. So right away now I'm going to go to this and say, okay, I'm going to just check these 3, 5, 7, 9. If it's odd, you always just go right to 3, 5, 7, 9. So let's check 3 to see if it could be a factor. 7 plus 1 is 8. Does 8 have a factor of 3? No. Does 5, remember the rule for 5 is, does it end in 5 or 0? No. The rule for 7, there really isn't a rule that can really help us. Okay? So just remember, if 7 times 10 is 70, obviously 71 doesn't have a factor of 7. And then we didn't go over the rule for 9, but it's the exact same rule as 3. So that means you add the digits and then ask yourself, is it divisible by 9? So 7 plus 1 is 8. 8 is not divisible by 9. Therefore, this is a prime number, 71. So we wouldn't write this. That's wrong. You would just simply circle 71 like that. And you would say 71. Its prime factorization is just 71. Okay? All right. So if you feel pretty good right now, this video went a little longer than I wanted it to. If you feel like you're all good with this, okay. If you can stop, you can be done. But if you want a little extra practice, I'm going to continue to do these 3 problems here, and then I'm actually going to go back and even do these really quickly. Okay, so if you want to continue watching, do. If you don't need to, that's fine. If you want to pause and try it and then listen, that's fine. I'll do them relatively quickly. Okay, so here, first thing I recognize is that's even, so I know it has a factor of 2, and I know that 2 is prime, and I know that 2 times 3 is 6, and I know 3 is prime. So my prime factorization for this would be 2 times 3. Remember, this is the answer. This is the answer. This is the answer. This is the answer, not the actual tree itself. Here, 15. I notice right away that it ends in a 5, so I know that it has a factor of 5. So just ask yourself, well, what would I multiply 5 by what to give me 15? And you get 3. I know that both those numbers are prime because they only have 2 factors. So I know this is going to be 3 times 5. Here, okay, there's a lot of options. I could notice that it's even and do 2 and 18, but maybe you just know your math facts really well. Maybe you know that 4 times 9 is 36. Maybe you know that 3 times 12 is 36. It doesn't matter. However you do it, it'll always work out the same way. So I know 4 is not prime, it's composite. So we got 2 and 2, and we got 3 and 3. So I know that my prime factorization is 2 times 2 times 3 times 3. Okay, and that's my answer. And then always multiply them and check it. Okay, let's go back to these prime and composite ones if you want to practice these. Okay, now it's kind of up above, but I'm going to try not to use those. Remember, first thing we identify, is it even or is it odd? Okay, so it's odd. So whenever it's odd, you go ahead and do 3, 5, 7, 9. Okay, you always check 3, 5, 7, 9. So I'm going to check 3. 4 plus 3 is 7. Does 7 have a factor of 3? No, it does not. Does it end in 5 or 0? It does not. Okay, really, no rule for 7, so you just got to be able to do in your head, does 43 have a factor of 7? No, it does not. Remember, the rule for 9 is the same as 3. 4 plus 3 is 7. Does 7 have a factor of 9? No, it doesn't. Therefore, this is absolutely a prime number. Let's go to number 2. Okay, first thing I identify, is it even or is it odd? Okay, it's odd, so we're going to do 3, 5, 7, 9. Start at 3. 4 plus 9 is 13. Does 13 have a factor of 3? Nope. Does it end in 5 or 0? Nope. Okay, 7. Got to remember that 7 times 7 is 49. So this has factors of 1, 7, and 49. Therefore, it is a composite number. Okay. The number 1, you might remember, would be neither because it only has 1 factor. 27 is odd. So again, we're going to check 3, 5, 7, and 9. Okay, so if you added it, 2 plus 7 is 9. Does 9 have a factor of 3? Yes, it does. Therefore, that has more than 2 factors. 17 is odd, so you're going to check 3, 5, 7, 9. You would learn that that is absolutely prime. 141, check this one. It's odd, so we're going to check 3. So 1 plus 4 plus 1 would be 6. Does 6 have a factor of 3? Yes, it does. Therefore, it has at least 3 factors. Composite. 51, 5 plus 1 is 6. 6 does have a factor of 3. Composite. And finally, 9 has a factor of 9, but it also has a factor of 3 because of 3 times 3, so that's composite as well. All right? See you guys.